All right. Well, thank you for the opportunity to present this analysis looking at both weather and pollen as a possible urologic chronic pelvic pain syndrome flare trigger in the multidisciplinary approach to the study of chronic pelvic pain, or MAP research network. I have nothing to disclose. Okay, so I just wanted to clarify before I started that in MAP, when we use the term urologic chronic pelvic pain syndrome, or UCPPS, that we're including both interstitial cystitis bladder pain syndrome and chronic prostatitis chronic pelvic pain syndrome. And so, as most of you probably know, UCPPS flares are quite common, but we don't really understand the etiology or what triggers them. However, there's limited data, mainly qualitative and some cross-sectional data from male patients, actually largely from Scandinavia, to suggest that cold, damp, and windy weather, lesser amounts of sunlight, and changes in weather worsen UCPPS symptoms and trigger flares. So to investigate this hypothesis further, we took advantage of some data that we had collected as part of a case crossover study of flare triggers in the MAP research network. And we did this in MAP1, which was a one-year longitudinal study conducted from 2009 to 12. And as part of that study, every 2 weeks, we asked participants whether they were currently experiencing a flare. And if they said yes, we asked them a few more questions, most importantly, flare start date. And we asked a similar set of questions or more information at 3 times when they didn't report a flare. And what this allowed us to do is make within-person comparisons of flare, non-flare time points. So given that we had those data, we then decided to link them to publicly available weather data, including temperature, relative humidity, barometric pressure, and UV index. And so to be included in the study, participants had to have both a flare and non-flare observation. So in the end, we had 290 participants, and that gave us a total of 573 flare observations and 792 non-flare observations. And I won't go through this for all 4 weather parameters, but just to give you an idea of the range of weather data that we had to analyze. So the MAP study is based in the United States, and we have 6 main sites and a few subsites. And they range from all the way to the northern part of the United States. So we have a site in Michigan all the way down to LA. So we had quite a bit of variability, but most of the sites would be having cold winters and warm or hot summers. So the first thing that we did was to look at daily values of each of the weather parameters in relation to flare onset. And because we don't really know how long it takes a trigger to result in a flare, we explored several different time frames. So we looked at weather on the day of a flare, weather the day before, which is day -1, 2 days before, day -2, and 3 days before, day -3. And then we looked at those in relation to flare onset. And what we found pretty much across the board was no association for any of these parameters. And then, this is a very busy slide, and I won't go through all of the results, but we did a large number of analyses to explore the idea that possibly changes in weather, because that's what participants had said to us, might be triggering flares. So we looked at changes in temperature, relative humidity, barometric pressure, and UV in each of the 3 sets of days before a flare. So yesterday to today, 2 days before to 1 day before, and so on. And so even though we saw a few possibly suggestive associations, the bottom line was we didn't really see any patterns there. And then lastly, to be very thorough in our investigation, we used all the longitudinal data that we had available to us, so all the every 2 weeks when they said they had a flare or not. So that gave us more flare observations, but a little less precise because we didn't ask more detail about those flares. So we also looked to see whether flare rates varied by season. And we looked at season in one of 2 ways. One, just the probably season that you're familiar with, the astronomical season, which is spring, summer, fall, and winter. And we also, just recognizing that really like winter starts earlier in the northern United States than it does in the southern United States, we also defined a photosynthetic season. So using maps of the United States, looking at vegetation, we were able to document when that started and ended. But pretty much we saw no association between season, however we defined it, and flare rates. So in conclusion, we found minimal evidence to suggest that weather triggers flares in most UCPPS patients. However, and this was an issue with our previous data in the case crossover study, we can't rule out the possibility that a smaller subset of patients are susceptible to the influence of weather because we're doing a population level analysis. So for instance, if let's say 10% of patients are susceptible, it would be quite hard to detect that association if we don't have a way of identifying those individuals. So we do plan to pursue this hypothesis further, doing N-of-1 analyses where we're collecting flare data using an app, so we should have more flare observations per participant to allow us to do N-of-1 analyses that we can link to weather. And in summary, I'd like to thank the NIDDK and the MAP study for funding this analysis. And now I think I'm going to try to move on to the pollen analysis.